Hello and welcome back, guys. So today we will be learning another very important and interesting IB maths topic of logarithms. Okay, so first let's understand what logarithm essentially means. Logarithm is basically a way to represent numbers. Okay, let me just write it over here. A way to represent numbers. Okay, like you write 1, 2, 3, things like that. For example, this is one way to represent numbers. Another way to represent numbers is another way could be yeah. So another way could be 1 power 2, 1 power yeah. So 2 power 2, 3 power 2, 4 power 2. This is exponential. Okay, this can be said denary. Okay, this is exponential. Similarly, there is the log form that could be represented as log of 3 to the base 4. Okay, log of 8 to the base 2, log of 7 to the base 5. Okay, it is read in that way, and by the way, this is not in order. Okay, so these are all ways of representing numbers. Okay, there are other representations as well, like the time is represented as a 60 in terms of 6 and 60. For example, 1 minute equals 60 seconds, then 1 hour equals 60 minutes, and this are in terms of 60, right? And here it is in terms of ones and twos. Then there is a denary as well, which is a more computer related term. So for the topic, we need to understand these ways to represent numbers, and logarithm is also one of the ways to represent numbers. Okay, so first of all, let's understand exponential form to better understand the logarithmic form. Okay, so exponential form is basically when there is a power, there is an exponent or a power or a rule, you can say. Okay, exponential. Okay, so for example, 2 power 2, this is an exponential number because it has a power of 2. Okay, and this 2 is the base, right? This is an exponential number. There are some rules of exponential numbers, and these could be written as follows. For example, I can say that a power m times a power n is equal to a power m plus n. Okay, as an example, it could be, we have the common bases, right? So it could be 4 power 3 times 4 power 5 is equal to 4 power 3 plus 5 or 4 power 8. Okay, you can even calculate it on your own and the answer would come the same. Okay, 4 power 8. Another rule is a power m divided by a power n is equal to a power m minus n. Okay, an example could be 4 power 3 over 4 power 5 is equal to 4 power 3 minus 5 is equal to 4 power minus 2. And this makes us go to the third rule, and that is a power minus x, let's say minus m for the order, for symmetry. You can say minus m is equal to 1 over a power m. Okay, so I'll take the same example over here. Okay, so over here it could be represented as 1 over 4, and the power would become positive in the denominator, so it would become 1 over 16. Okay, so these are some basic rules of exponents. Okay, and you may already be familiar with these. You may have learned these in your maths courses in your earlier years. Okay, but this is just a revision of those. Another I just remembered is something like a power 1 over m is equal to mth root of a. Okay, for example, if we have a number like 4 power 1 over 2, it's going to be represented as the square root of 4. Okay, and square root of 4 is 2. So basically it means that we have to write this under root symbol, and the denominator, the m, would be the power of this. Okay, and obviously, as we have seen that a power minus m is equal to 1 over am, it could be the other way around as well. For example, if we have 1 over 4 power 3, would be represented as 4 power minus 3 as well. Okay, so this are some basic rules of exponential numbers. Okay, if now that we've learned about exponential form, we've understood exponential functions, it's fairly easy to understand logarithmic functions. Okay, so logarithm is basically a way to represent numbers, as we just discussed. Okay, so how do we represent numbers in logarithmic forms? So this is fairly easy to understand. Just stick with me and understand it with ease. Okay, so for example, if we have 2, we have to represent this number as logarithm. Okay, so what I'll go in the power of 10. Okay, so what is the power 10 squared? Okay, that is 100. So this is basic representation of the number 2. Okay, 2 could also be equal to log of 10, log of, let's say, 4 to 16. Okay, basically whatever the base is, I have to square it to get the power. Okay, and that is the representation of a logarithmic number. Okay, so let me just define simple rules of it, okay, for you to understand what that actually means. For example, if we have a power that is m and we have to represent that in logarithmic form, what we do is log of any number a, and then we have a power m. Okay, and that gives us the rule. Okay, and it can also be seen from over here that, for example, if we have m, which is 2, then it would be log of a, which is a could be any number, and then a power m is basically 4 squared, that is 16 over here, and when we do a power m, it comes a power m. So this leads us to general rules of logarithm. Okay, and general rules of logarithm include rule number 1 is that as we see over here, that log of a 2 is equal to let me just not write 2, I'll write n. Okay, is equal to n. Okay, so basically when we have a log completed, for example, a log consists of a base, base and then a power, or it could be represented as log of a to the base a. Okay, when we have this form over here, so log of the n could come down, and instead of power, like if we have an extra power of a over here, it could also be written as, let's say, a plus 4, and when there is a whole power over here, then n would always come down. Okay, and let me just for the sake of clarity, I will write it as, let's say, b power n. Okay, so n will come down and then the rest of it would come as it is. Okay, rule number 2 is that log of b is equal to 1. That is the very reason that when we had log of a over here, that became 1, and when m came down, so then m multiplied by 1 was equal to m. Okay, the next rule is simply that the simple which is similar to the exponential addition division, addition, subtraction, multiplication, when and the rule goes as follows, that log of 4, or let's say a common base I will take as a, log of a to power b plus log of a to the power c would be equal to log of a to the power, sorry, I'm just like doing it in my head. Actually it is log of bc to the base a, not to the power but to the base. Okay, and this is how we represent it. Like in over here we see that when the powers are multiplying, the numbers are multiplying, the powers add, right? And here it is the opposite. When the numbers are adding, their powers or their exponents, they multiply. Okay, so it is a similar with the division thing. Okay, you can even guess and post your guesses in comments what would be when log of ab minus log of ac happens. Okay, and I'll give you 2-3 seconds to guess. Okay, so it is basically log of a b over c, because here it was multiply, now it would be divide. Okay, so that is some basic rules of logarithm. Okay, and another rule could be that whenever there is a log of 1, rule 5 can be, whenever there is a log of any number to 1, it is always 0. Then rule 6 is rule 6 can be that log of, let's say we have two numbers, log of b a, and it could be represented as log of b to any number, log of c to the base b, like c could be any number, and then we have no, sorry, actually it is a over here. Okay, log of a over log of b to any number. Okay, so both these expressions are basically equal. Okay, and another thing could be, even though it is like not very necessary, but like an exponential rule basically, it could be that a power log of ax, basically log of x to the base a, is basically equal to x. Okay, so that is it for logarithms. Thank you for watching.